Hello, welcome. Today we're going to be talking about acceleration, but this time mathematically, standard 1.10. We've already seen in standard 1.9 what acceleration means. Acceleration is just that the velocity is changing over time. So for example, if I'm looking at displacement over time, and I see a graph that looks like this one here, well, I know the displacement over time, final displacement equals velocity times time plus initial displacement. I know the slope of this line here is equal to its velocity. Now I see that each point on this line has a different slope. If I were to find the slope at this first point here, well, it would be the slope of this line that I've just drawn that's right next to the line. If I were to find the slope at this point, well, it would be the slope at this point that's right next to the line. And so each point here has a different slope. If I find all those slopes, well, I can plot them as velocity. So whatever time this is, I can find the same time here and plot its velocity. The velocity is changing as time goes on. The velocity could be increasing, like we see in this first graph, or it could be decreasing, like we see in the second graph. And this second graph, the velocity time graph, well, I say I have velocity and time. If I think about y equals mx plus b, well, my y in this case is velocity, is equal to the slope. The slope of this line is going to be velocity over time, how velocity changes over time, which is equal to acceleration. So that's going to be my slope is acceleration. X in this case is time, and my y interval, b, my y interval is going to be whatever my velocity is at no time, my initial velocity. And so that's how we get this equation that you can find in your formula book. So if I had a situation like this, a race car is accelerating uniformly, just means constant acceleration. That whatever the acceleration is, however much faster my velocity is getting every second, that's not changing. We're only going to deal with constant acceleration. For velocity, we'll have constant velocity or changing velocity. For acceleration, we're only going to deal in this class with constant acceleration. That's as far as we're going to go. So uniformly is just saying that at every second, however much faster the car is getting, it's getting that amount faster from second 2 to 3. And then again, that amount faster from second 3 to 4, that the acceleration doesn't change. All right, so race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second in this much time. Find its acceleration. So I already know I could do this on a graph. I could graph these points in a velocity time graph, find 18.5 and 46.1. 18.5 is at 0 seconds. 46.1 is at 2.47 seconds. So I could get a line here. And then if I found the slope of this line, that would be equal to the velocity over time, which is acceleration. What I'm seeing is I can actually just go directly into using this equation. So in standard 1.9, we did this graphically. In standard 1.10, you can draw a graph if that's helpful for you, but we're really just going to go directly into this equation. So my plan here, I'm going to use the equation. It's given to me, velocity equals acceleration times time plus initial velocity. And I'm just going to figure out what I have. So I have a final velocity, 46.1 meters per second. This one I have. Acceleration is what I'm looking for. I have a time, which is 2.47 seconds. And I have an initial velocity. The initial velocity is 18.5 meters per second. So now I'm just going to do my algebra. I have my equation, V equals AT plus VI. My final velocity was 46.1 meters per second equals acceleration I don't know. My time is 2.47 seconds plus 18.5 meters per second. All right, I'm just going to put it in terms of just numbers to make it a little bit easier for me to solve. 2.47a plus 18.5. First thing I'm going to do, get like terms together. I'm going to subtract 18.5 from both sides, and I get 27.6 equals 2.47a. And now to get a by itself, all I need to do is divide by 2.47. Divide by 2.47 on this side, and my acceleration is going to be equal to 11.2 meters per second squared. The unit is meters per second squared for acceleration because I'm dividing velocity, which is meters per second, by time, which is seconds. And so I get the unit of meters per second squared. Thanks for watching. Let your teacher know what questions you have. Have a good day.